terms on a finite geometric sequence. These are our sequences, and although we can see here ellipses at the end, we can still refer to them as finite sequence in this particular topic because we are talking about a finite number of terms in each sequence. Example 1. Find the sum of the first 6 terms of 4, 12, 36, and so on. When I am solving a problem like this, I would like to think about the formula. The formula is this one: S sub n equals A sub 1 times the quantity 1 minus r raised to n all over 1 minus r, where r is not equal to 1. I think of the formula so that I will know if the quantities in the formula are given in the problem. So we are given that the first term is equal to 4, the common ratio is 3, y, 12 divided by 4 equals 3, and n equals 6. So writing our formula, and then substituting, S sub 6 is therefore equal to A sub 1 or 4 times the quantity 1 minus 3 raised to the 6th all over 1 minus r or 1 minus 3. That gives us, okay, we're going to simplify this. We will start with the numbers inside the parentheses. That will be 4 times the quantity 1 minus 729. 3 to the 6th power is 729. All over 1 minus 3, negative 2. Now 4 happens to be divisible by 2, or negative 2. So we will divide. Thus, S sub 6 will be equal to 4 divided by negative 2 is negative 2. And then inside the parentheses, we have 1 minus 729. So that is negative 728. And multiplying these two, the final answer will be 1456 positive. Number 2. Find the sum of the first 7 terms of 3, negative 6, 12, negative 24. So again, that's our formula. We are given that A sub 1 equals 3, R equals negative 2, negative 6 divided by 3 is negative 2, N is equal to 7, because we are finding the sum of 7 terms. Substituting into our formula, S7 or S sub 7 is equal to A sub 1, 3, times the quantity 1 minus R, negative 2, raised to the 7. Now, our negative 2 must be placed inside parentheses. That is very important because it's negative. If we don't place negative 2 inside parentheses, okay, there is a big chance that it will affect our answer. Then, all over 1 minus r, that is 1 minus negative 2. So we work on the numbers inside the parentheses. We have 3 times 1 minus negative 2 raised to the 7th power is negative 120. Then all over 1 minus negative 2 is positive 3. Then we can see here that 3 is divisible by 3. So we are left with S sub 7 is equal to, now this 1 minus negative will become 1 plus 120. 1 plus 120. So our final answer is 129. That is S sub 7. That is the sum of the first 7 terms of the given sequence. Third example. Find the sum of the first 18 terms of 4, negative 4, 4, negative 4, and so on. In this problem, we are given that the first term, A sub 1 is 4, the common ratio is negative 1, and n is equal to 18. The given formula is also not applicable in this case. Let's take a second look on the numbers. We have 4, negative 4, 4, negative 4, 4, negative 4. Now, this 4 and negative 4 added together will give us 0. And same with the third and the fourth. Then for the next two also. Which means to say that for every pair of numbers, a positive and then a negative number, the sum will be 0. And since there are 18 terms, all the numbers will be in a pair. So therefore, we can say that When the common ratio r is equal to -1 and n is an even number, the sum of the first n terms will be 0. Again, because the number of terms is even, all the terms will be in a pair, can be grouped as pairs, wherein each pair will give a sum of 0. Therefore, the final sum will still be 0. So in this case, S sub 18 is also equal to 0. Next, find the sum of the first 11 terms of 4, -4, 4, -4. We still have the same numbers, 4, -4, but we changed the number of terms. So again, first term a sub 1 is equal to 4, r equals -1, and n is equal to 11 this time. So let's observe again. We have 4, -4, 4, -4, 4, and so on. So the first pair will give a 0 sum. The next pair will give a sum of 0 also. All the pairs will give a sum of 0, but since the number of terms is an odd number, there will always be a remaining one term which doesn't have a pair. So that when you find the sum of all the zeros and the last number, then the last number will be the sum. But the last number will also be the same as the first one. First one, or which we call a sub 1, or first term. Thus, when the common ratio equals -1 and n is an odd number, the sum will be equal to the first term, a sub 1. So in this case, our S sub 11 is equal to 4. Next example. Find the sum of the first 12 terms of 2/3, 2/3, 2/3, 2/3. Now in this case, okay, a sub 1 equals 2/3, r is equal to 1, n is equal to 12. So obviously, the formula used in number 1 and number 2 cannot be used here because r is equal to 1. So we can say that the sum, or S sub n, is equal to n times a sub 1. Why? Since all the numbers are just the same or equal, so to find the sum, you can just multiply the number of terms by the first term, because all the other terms are equal to the first term. So S sub n equals n times a sub 1. Okay? Or S sub n equals n a sub 1. We can write it this way or this way. So S sub 12 is equal to 12 times a sub 1, where our a sub 1 is 2/3. So 12 times 2 is 24 divided by 3, 8. So S sub 12 equals 8. So if you understood the lesson and the discussion, can you try to find the sum of these 5 sequences?